Hey, welcome back, everybody. It's time for Making a Connection, brought to you by ANTAIRA. The one show, the only show that talks about the difficulties and challenges, making a connection with all the stuff out there today, keeping it connected. And today, we've got a fascinating sub-part of that story. We're going to talk about intelligent transportation systems with Melody Lynn from ANTAIRA. Welcome.
Thank you so much. First-time podcaster, so I'm very excited to be here.
They tell me you're an expert in this here, so we're going to find out here. Do you really understand what is an intelligent transportation system? Let's talk about this. It's not just roads anymore. It's not just a pavement and stop signs and a few red lights overhead. What is it? What's an intelligent operation system? How do you define it?
Yeah, so Intelligent Transportation Systems, or ITS for short, has definitely come a long way over the years. From those simple street lights and road signs that you mentioned. In today's world, our roadways and transportation systems use a lot of what we call high power cameras and sensors that are integrated with advanced algorithms for traffic reporting, monitoring, and management. And that is where ANTAIRA's solutions come in.
All right. Well, that's a mouthful. So let's see if we can break it down a little bit here. We're at the University of California, Irvine's Beale Applied Innovation Center. That's where our studio is. So we hear all these innovative, futuristic technologies that come through. They're either in the building or they have conferences downstairs. And yesterday they had a conference called Sustainable OC. I think that's what it was called. And they talked about this topic. It's ironic. It's fortuitous. Here you come in today to talk about it, and I heard somebody talk about it just yesterday. Until then, I'd never even heard the term intelligent transportation systems. But we had, as part of this conference, they had the mayor of Irvine. We're in Irvine here, California. And she came in with her transportation chief, or whatever they call this person. And they have, it looks like out of some movie, some sci-fi war room, where somebody sits 24/7 and looks at all the cameras from all the different intersections and monitors the traffic and the sensors that must be embedded in the road at that point and decides, do we speed up the red lights? Do we slow them down? There's a special event in the city here. We better get the traffic flowing here. It's breaking down. We better start rerouting. This is like out of the future. I had no idea. Irvine, California has a 24/7 transportation hub. Have you ever, you must have, you've seen these things? Are they becoming more common?
They are. A lot of cities, especially in Southern California, have these large 24/7 monitored transportation management centers, or TMCs, as we call them for short.
Okay.
Yeah, City of Anaheim has quite a large one as well.
And so in this center, there is somebody trying to take all this data that's been embedded out in the road. What kind of stuff are they looking at? They're looking at certainly the red lights and the green lights. They're looking at cameras that can see what's actually happening. Do they have sensors in the road yet that are telling how many people go over the bump at a certain time?
Yeah. And I'm sure you've seen this technology on the road too as you're driving across intersections, but oftentimes there's a ring right in front of the traffic lights where if the car is on it, then the traffic lights will know to change from red to green and all that. And so our switches are able to communicate that data from the traffic intersections to the TMCs.
So all this data is flowing back in, and somebody's sitting there monitoring it, a human's deciding this is flowing good, this is flowing bad here. What are the stuff? What about the power requirements? How are they powering this stuff? Is it all solar?
Yeah.
At least here in Southern California. Right?
Yes, I was just going to say, especially in Southern California, we get a lot of sun.
Yeah.
And a big trend we're seeing is more solar applications in transportation. So it's critical not only to have what we call a low voltage power input with the solar application, but also making sure we're supplying enough power to the connected devices, oftentimes which are high power cameras.
So let's get a little technical here. Low power is what, 12 volt DC like I have in my solar lights in my yard here or something?
Yeah, 12 to 24 volts DC is what we consider low voltage, which is commonly used in solar, as well as onboard applications such as on buses, electrical buses. We work with a couple projects.
Really? What the heck is an electrical bus? What does that do?
Yeah, so rather than using gas,
Right.
It's powered by electricity.
And these buses have some sort of sensors on them that monitor what? How fast they go, or how many people get on and off, or payment, or what are they monitoring on a bus?
Yeah, they also have cameras on the buses,
Okay,
of
yeah.
course, for security purposes. But also, like you said, there's ticketing systems on buses, so all that requires data.
And some of this stuff uses low power, might use 12 volt, might use 24 volt. And this would support what? Smaller cameras? In the notes here it says a 60-watt camera. And then there goes up to what? 90-watt cameras. Now you need 48 volts. You need more. This is all DC. This isn't alternating current. This is direct current, right?
Yeah, that's
like a
correct.
battery.
Yeah.
Right?
So you mentioned 90-watt cameras. So ANTAIRA has a whole line of what we call 90-watt BT switches, as well as injectors that are able to power these high-power cameras.
What's BT stand for? Big thing? It's a big thing. No, I don't know.
Yeah, I'm not sure what BT stands for either, but it is a triple E 802.3 power over Ethernet standard.
That's a fascinating whole idea. We talked about this once before. The idea that Ethernet switches aren't just sending data anymore. They can send power. If you have the right kind of, I have one here in the studio because we have some cameras that now we'll use. You can go into that Ethernet cable and send data, the video images and stuff over this back to the main computer that's switching all this. In the old days, have to have lots of different cables running for 50 feet, 100 feet back to some point. Not doing that anymore, right?
Yeah, so many more legacy traditional devices use what we call AC power, which a lot of people are more familiar with, but they're definitely moving towards being powered by PoE, power over Ethernet, such as signal controllers. They have web interfaces now that require Ethernet.
And that's only got one wire then carrying not just the data, but the power as well to all these things here, back and forth.
Yeah.
All right, that makes more sense. And is it easier to carry data and power over an Ethernet cable? That seems like you're making something that was designed for one purpose, try and do something else here. Does that mean it's not as efficient at transmitting energy, or is it just as good?
Of course, it's just as good. So basically our PoE switches and injectors are our bread and butter. It's definitely what we do best.
Okay. So you guys have these things, and you can deliver data, you can deliver power, but you got to deliver it to a variety of devices. Is it capable of doing that? Can it handle different low power, different higher power, different sorts of requirements? Does it have a lot of capability to it here? And how much capability do you have to have? Sounds like more and more. They keep adapting and adopting new standards.
Yes, definitely new standards, new features. So it's really important in the initial design phase to really hammer out what the specifications of the product you need in your network is, whether that's with the city or with the Department of Transportation. We have what we call our managed switches, which basically are designed with features that make a traffic engineer's life easier, whether that's managing a network or being able to monitor it clearly.
All right, let's get into the detail, the weeds for 1 minute here until I get totally lost in the weeds here. They told me to ask you about ANTAIRA's high port count DIN rail and 10G rack mount switches. That sounds like English, but I have no idea what any of that means here. So let's start with, what is a high port count DIN rail? What the heck is that?
So we call it a DIN rail switch, which basically snaps onto a DIN rail that you see quite often in traffic cabinets.
I don't even know what a DIN rail is.
It's like a metal rail that
Help
is
us
designed.
out here. Henry's in the back here. What's a DIN rail look like here?
It's a little metal bracket that you can actually attach to a cabinet, and it has the lips where the actual device will lock into on it.
Okay, it's a little rail somehow, and everything
That's
locks
right.
into it here. He's saying off camera here. All right, so we've got this DIN rail. That must be something that's common. And why do I need a high port count? You're saying I only need one connection. I got a power over internet, and so I got the power and I got the internet. What do I need any more stuff for? But you're saying cameras and other sorts of things.
Yeah, especially in traffic applications, we're seeing more and more demand for switches that require 4 or more what we call fiber ports. I think we were just chatting up with Henry about this, but a lot of cities have what we call dark fiber that are currently...
Now that sounds scary. My city has dark fiber. Is that like the dark force that's lurking down there? And what is dark fiber? I guess it's simply when they put the cable in there, they had extra capability built into it? There's fibers that aren't being used.
Yes, fiber that's not being used
Sitting
in a
dark.
nutshell. Yeah, sitting dark. And with more and more, connected vehicle, cameras at intersections and other devices that are being connected to the network, these dark fiber runs are being activated, which calls for switches that have more and more fiber ports and more Ethernet ports that can support all these devices.
Because the thing, I've got to plug in more stuff, and I got to have more ports, and I got to
That's
push
right.
more data, and all this other stuff, maybe even more power. So you're keeping up with this. You're now seeing switchers that have more ports. I guess that's it. A high port count. There's more than just a couple now.
There are, yeah, we have anything from our lowest port counts 5 ports all the way up to 20,
Wow.
yeah, 20 ports now, I want to
At
say.
an intersection, there's 20 things. I'm gonna have to think
Yes.
hard. What
Yeah.
what 20 things they plug into it? And then what's this 16 copper ports and 12 fiber? What's the difference between a copper port and a fiber port?
Yeah, so copper would be your Ethernet or power over Ethernet ports, and then your fiber ports would be the ones that you use
Because
for
the
your
copper is how they.
SFPs.
That
Yeah.
makes sense. Duh. Okay. Copper is how they transmit the electricity, the energy. Right. All right. So you've got you're building these things with lots of copper ports, lots of fiber ports. They're adaptable, and they are adapting to the increasing number of devices that cities and municipalities and city traffic engineers are now looking to plug into these things and send data back to them wherever the central location is.
That's right, yeah. And because they are DIN rail, and we definitely designed them with those smaller form factors in mind, so you're able to fit into the very valuable real estate that's in traffic cabinets.
Yeah, boy, I'll bet.
Yeah.
What is the traffic? I've seen them open up on the sides sometimes. It's a little box with a lot of stuff crammed in there.
That is right.
And so these things have got to effectively fit in there and connect as much stuff as possible here. What else about setting them up is what do they call it? The GUI, graphical user interface. Is this idiot proof, or would an idiot like me fall apart when I try and plug this stuff? I know they're not going to hire me to do it, but I don't know who they're hiring. Is this a regular minimum wage employee that's going out and doing this, or some high-tech engineer that they get sent out? I don't know who sets this stuff up.
So with a graphical user interface, or GUI, as we call it for short, you're basically able to access it through a web browser. So it is simple enough that even I can do it.
That's what I'm
Head up
getting
there
at.
and
So,
configure the switches.
because I'll bet if you go from city to city, there are some people that are just in the maintenance department. No knock about the maintenance department, but they're not technical people. They're used to making sure the signs are up and the road is clear. They're not necessarily IT people out there trying to interconnect complicated stuff, in which case it would all fall apart.
That's right, yeah. So that's where a lot of ANTAIRA support comes into play, whether that's our technical support team or our field application engineers, who you may have heard from on other podcast episodes.
Yeah.
But yeah, but that's definitely where they come in to help out any electrical engineer, traffic engineer that is using ANTAIRA.
Because this stuff is worthless if it doesn't work. All the stuff they paid for, if the simple thing doesn't connect or goes down, now we got a big problem. There's no data, there's no power, the light's not working, and nobody knows what's going on out there. And which means I got to send a team out to figure it out, and probably not my team. Maybe it's the vendor's team or a couple of vendors' team, which takes time to get there. In the meantime, it's down.
Yeah, so we have developed quite a few features that are either hardware or firmware features that help mitigate this or minimize downtime out in the field.
That would seem to be the worst. It's not just setting it up, it's keeping it up.
Yes, that's right. Yeah. So a feature called Ping Alive. Again, probably have talked about it in
We
other
did.
episodes. Yeah.
It was such an obvious one. Let's just go through that one more time here quickly. But Ping Alive is simply, I picture this. I remember reading, maybe this is a weird example, but years ago they had that Malaysian airliner that disappeared. And they don't know what happened. Pilot went crazy, the depressurization, something happened, and the plane turned around and went where it's not supposed to. Another reason they know that is because it kept pinging. It kept sending a ping to check in every so often to tell the world, the traffic controllers, I'm still here. And that ping was what allowed them to track it, where the ping was coming from. So even if the whole crew was dead and they thought something horrible happened, I don't know what it was, getting dark, mysterious stories here, but whatever it was, the computer stayed alive and kept pinging and talking to the network. Is that what now your switches will do? They keep talking. We're still here.
Yeah, it's a really similar feature than the example that you just provided. But basically, if you turn on or enable the ping alive feature in the web GUI,
The web GUI and the
web
ping alive.
GUI, and you add in the power device or the connected device, such as the camera's IP address in there, and then you set what we call a ping interval time. So that can be like 30 seconds, 60 seconds, 90 seconds. And the switch will start sending pings to this connected device at the designated intervals to determine if it is still active or alive.
Right.
Yeah.
Otherwise, somebody's got to go out and look at the darn thing.
That's right, yeah. And if it does detect inactivity after 3 pings, then it automatically reboots that one specific PoE port.
See, there
so
you go.
Oftentimes
Resets
with
itself.
Correct, yeah. Oftentimes all it needs is a reset. I'm sure you've called technical support before and all they say is, oh,
My
why don't
cable
you turn
TV,
it on and off?
yeah, and from wherever they're sitting, all of a sudden they turn my cable TV on or off, and
Yeah.
that's it. The whole thing resets and it works. In the
That's
old
right.
days, I had to wait 4 days to get somebody to drive out and pay them $50 or $100 to show up and flick a switch.
Mm-hmm. Yeah, so you save all that time with all the city engineers. It's valuable time and resources that go into that.
I'll bet. All right, last question. So you're trying to connect all this data, and it sounds like, what are they? Give me some ideas of what they're connecting. They're not only the traffic light itself, but there is some sort of sensor or camera determining the flow of traffic, right? They're trying to keep the traffic
Yeah.
flowing and not backed up.
Yeah, like we mentioned at the beginning, a lot of cameras nowadays have a lot of built-in algorithms that are able to help monitor traffic and manage traffic, all from the TMC end.
Right. All right. And I wonder, as we move to electric vehicles, will they ever, there seems like a fantasy to me, but will there be sensors connecting that or sending data that the local electric vehicle can pick up on and say, oh, there's something ahead and I better adapt or adopt, sort of like a GPS thing that's being sent through the internet or something. There's some traffic ahead, problem ahead, or sensors on the side of the road. They're talking about all sorts of crazy stuff. I don't know who's going to embed all this stuff, and I know who's going to connect it all. It's companies like ANTAIRA.
That's right, yeah.
Yeah. All right, so lots of stuff coming, more than we've ever imagined here as they collect more and more data at traffic intersections. It's mostly the intersections, right?
That's right.
Right now they're not just doing it in the road, but
Yeah, intersections, freeways,
all that
all
stuff.
that.
And all of this needs to have a switcher. And all this has to have some way to get that data onto an internet and back. That simple device, which you guys specialize in.
That's
Wow.
right.
And it's got to work in what? Heat and cold and severe weather and stress and I don't know what sort of challenges out in the environment. This can't be just a thing from Best Buy.
No, it cannot. We specialize in industrial Ethernet switches in the transportation
So
space.
they're hardened.
They are ruggedized. In the transportation space, there is a certification we call NEMA TS2. Essentially, it's a temperature rating from -40 to 74 degrees
Wow.
Celsius, if I remember
Okay.
correctly. Yeah, and our switches meet that with the extended operating
So it's
temperature.
rugged, it won't break, it's got more
Yeah.
resistant to heat and temperatures, and there must be other sorts of things that happen too. I don't know what. Any horror stories? Think about it. You go back, tell us sometime future horror stories of what happens out there to this stuff.
Yeah, I just know that these switches work in, the Arizona desert, as we like to call it,
Yeah.
all the way up to, if you've ever been up north to the Yukon territories up in Canada.
Yeah, right. Big severe weather differences there. All right, so you've got to make them rugged and everything, and then they have to have more backups. They got to ping themselves. They got to be able to reset them. They got to stay up. They got to keep working all the time. And that's what you guys focus on doing through all these crazy things. So talk about solar. Is there anything you have to do? How do you keep solar? How do you bring solar power into the system here? And is solar have any different challenges to it?
Yeah, so let's say you have a camera that probably requires, 70 watts or more power, but you give it a 60-watt power supply. It's not enough power to be able to power the camera, no strain on those components. For, like we mentioned, for solar applications, we have what we call our low voltage input injectors and switches that have a built-in power booster that's able to boost the power all the way up to 90, 100 watts to be able to power those high power cameras and devices.
Wow.
Yeah.
Okay. Amazing stuff here. And I wondered they must monitor the power coming back, and they have all sorts of other sophisticated stuff they're trying to check with.
That's right. Yeah. In our managed switches in the web GUI web interface, there is a menu where you're able to monitor the PoE power.
And you can probably do it on a smartphone or something.
You could do it on your laptop or computer. Yeah.
Wherever that traffic engineer is, he's at home on a Saturday night, or he's driving somewhere, or whatever, and people say, it went down. And he can log on, he or she can log on and suddenly start accessing this data and determining, can we fix it remotely, or do we have to get a crew out there quickly? Amazing stuff here. Do you guys ever work with training people? Do you ever do any sort of lab testing or any of this stuff on here, or are you just making them?
Oh, we have an awesome technical support and FAE team back at our office down here in SoCal. We worked with DOTs, Department of Transportations, and cities quite closely in terms of providing them support. Would you like a story?
Please. I'm always looking for stories. I'm a storyteller, so yeah.
Let's do it. So, for example, with a DOT that we worked with recently, they wanted to move away from what we call a proprietary ring protocol or topology into something that's an open standard, which is what ANTAIRA does.
And this whole idea of sort of like what do they call it? That's what is the Chrome browsers and all these things. Linux, open things that anybody can go in and modify, as opposed to something somebody proprietary just built, and that company goes out of business. We're in tough luck here.
Yeah, you don't want to be tied down to only one vendor or brand.
Right.
So that's definitely the benefit of an open source standard.
Right, yeah.
So our ANTAIRA FAE was able to conduct 3 different virtual video conferences.
What's an FAE?
Field Application Engineer.
Okay, all right.
Yeah,
we all got these acronyms here.
We do. That is the technical space for you.
So one of your FAEs out in the field was able to do what?
3 video conferencing meetings to basically assist them from the design and phase all the way to after install. So we went all the way from introducing an overview of ANTAIRA switches and our technology to making sure it meets their networking needs. And then we also conducted a virtual lab where we had the whole setup in our office, and we were able to walk the traffic engineer through how to get experience and how to set up their network, redundancy, and connecting it to their head-end switch and all that jazz. And then, of course, after they installed the switches into their networks, we set up a call, final review, and follow-up to make sure that they didn't have any questions or required any additional support. And yeah, everything went swimmingly because we were able to support them.
You're virtually standing right beside them there saying, okay, look at this. Let me show you this. Have you tried? No, don't do that. Try it this way. It's easier. No, this is how it works. And teach them how to do this stuff, because they didn't go to school. The city traffic engineers didn't go to IT school, I'll bet.
Probably not.
You know, and just because they're an engineer, Henry talked about this in the previous episode, just because you're an engineer doesn't mean you know all the ins and outs of all the technology out there today.
There are all the protocols out there, all the standards out there. No one can know them all.
Yeah, exactly. Well, that's what you guys are for, and
that
you can.
What we're
it
for.
Sounds like you work with people from not only making sure you come up with the right plan, but implementing the plan and then standing beside it. Suddenly, when there's a problem, you're there and you can help them, because it's all about keeping it. Making a connection and keeping it connected. We should add something to the show. It's not just about making a connection; it's keeping it connected too.
Keeping it connected.
I think that's the next part of our show here. Well, I thank you for joining us here today. And so in your job, do you just contact city traffic engineers? Do you work with them? What do you specifically do?
We work with
What
consultants.
you do, but you
what do I do?
Yeah. Other than trying to explain this complicated technology to the world here.
We work with partners in the transportation space that we have to bid on city projects, Department of Transportation projects, and basically read through specifications and recommend the best fit product.
I was going to say, do you ever make recommendations? Or
We do.
You're not just saying, if you did it this way, it might work a little better here. Yeah. What if we put this in?
Yeah.
All right. Fascinating stuff. I hope you'll come back and give us some more real-life examples of what you're really seeing out there, because the whole world is trying to make a connection, and I'm not sure they're really ready or know how to do it yet. Thanks for joining us here today.
Thanks so much for having me.
Well, there you have it, folks. Wow. I'm not even sure. I'm going to have to listen to this twice just to make sure I understand it all here. It's a complicated world that's getting even more interconnected, and that means there's a challenge making a connection. Tune in every week as we talk more about those challenges and how people are facing them with products like those from ANTAIRA.